All right, number 62. These problems are interesting. Rank the temperatures in each group from lowest to highest. A, you have 0 degrees Fahrenheit, 0 Celsius, 0 Kelvin, and then B, 100 Fahrenheit, 100 Celsius, 100 Kelvin. Okay, it'll be interesting to see which one, which numbers are hotter temperatures. And to do this, you need to know the temperature conversion equation. So these are given in section 1.9 of your textbook. So section 1.9. And so for part A, a good way to do this is just to convert them all to the same type of degree. Okay, so if you want to keep everything and compare everything in Celsius, then convert this to Celsius and convert that to Celsius. So how about let's do that. Let's convert everything to Celsius. So how do you turn 0 Fahrenheit into Celsius? Well, you'll use this equation. You plug in 0 Fahrenheit right here, and then you calculate what the Celsius is. So here, you're going to have 0 minus 32 over, squiggly line, over 1.8. And that's going to be equal to, let's do the calculation. So 0 minus 32, let's parenthesize that, over 1.8, I get negative 17.77. So negative 17.77 Celsius. Okay, so now we got that in Celsius. So I think I'll highlight the Celsius as blue. So this is now in Celsius. And let's turn the Kelvin into Celsius. So 0 Kelvin, to get to Celsius, you're going to use this equation. So 0 minus 273, pretty easy. 0 minus 273.15. And that's going to be equal to negative 273.15 Celsius. And there you go. Now we can compare apples to apples, and you can clearly see that the lowest one is 0 Kelvin. The hottest one is 0 Celsius. So this is the coldest up here. So here's the coldest, and here's the hottest. So I wonder if Celsius degrees are always when the numbers are all the same. Is this trend what you always see? The Kelvins are always coldest, the Celsius are always hottest, and the Fahrenheits are always in the middle. What do you think? I know the answer. So let's check 100 Fahrenheit, Celsius, and Kelvin. Okay, to do the same thing, we'll convert them all to Celsius. We'll keep this 100 Celsius. And so 100 Fahrenheit to Celsius. So take 100 minus 32 over 1.8. And then that's going to be equal to, so 100 minus 32 over 1.8. 37.77. So 37.78 Celsius. Now we got that one. And then the Kelvin, this is going to be, make sure you can see that. The Kelvin, this is going to be 100 minus 273.15, and that's going to be equal to negative 173.15 Celsius. So again, you see The kelvins are the coldest, and comparing these two, the Celsius is the hottest. Okay. Now you might think that that's always the case, but I'll tell you that there is the kelvins are always going to be coldest. When the numbers are all the same, the Kelvin number will be the coldest, but at some point the Fahrenheit will be hotter than Celsius. Okay? And the question is, what is that tipping point? If you look at the let me show you the picture in the textbook. If you look at this figure 1.8 in the textbook, it kind of lines up the Kelvin, Celsius, and Fahrenheit scales. there there is some point at which Celsius and Fahrenheit numbers are equal. Okay? So it's going to happen somewhere down here. Okay? So maybe I should put that in as a bonus problem. So down here, make a little star. Okay, star. Sounds like a good quiz or test bonus problem. What unique number does temperature Fahrenheit equal temperature Celsius? So in other words, what I'm asking is negative 23 Fahrenheit equal to negative 23 Celsius? And the answer is no. Maybe it's another number. So how about negative 37 Fahrenheit equal to negative 37 Celsius? And the answer is no. Okay? So what is the unique number that does where the two are equal? Okay, I think I'm going to ask that.